بسم الله الرحمن الرحيم. أبناء الطلبة، سواء في كيمياء عضوية 2 أو كيمياء عضوية غير الطلبة 232 أو 233، ها قد عدنا مجددا في موضوع مشترك لكم اثنين، اللي هو الالكوهولز and phenols. الالكوهولز والفينولز هو chapter 17 كيمياء عضوية 2، وشابتر راح يكون شابتر 7 لكيمياء عضوية غير طلبة. أول إشي بدنا نحكي فيه، هذا هو الموضوع المشترك الوحيد بينكم، اللي هو naming of alcohols and phenols. فالآن بنتحدث عن naming of alcohols and phenols. كالعادة في naming of alcohols and phenols we select every time the longest carbon chain containing the hydroxy group. فدائما we look for the longest chain containing the OH group, and OH group has the priority over any group except carbonyl group in the manner of naming. Any compound containing OH has to end up with all unless it has carbonyl group. So it's clear now. OH group has the priority over all groups except carbonyl group. يعني أي compound في OH group راح ينتهي في all ما لم يحتوي هذا الكومباوند على carbonyl group، وبكون البيزك نيم أو البيرنت number of carbons carbon atoms end up with all suffix. all أخذت البيزك نيم وراح تأخذ the nearest position to the end. هي كمان لازم تأخذ أقرب رقم في تشين للإند، أقل رقم. تسمى كالعادة substituents، دائما بكونوا حسب الألفابت يكتبوا، ولن يكون لهم أي تأثير من ناحية numbering of position unless OH has the same position to the two ends or different ends. إلا إذا كانت ال OH لها نفس البعد عن جميع الأطراف، ساعتها بنغلب الألفابت للسبستيتيونتس. Let's have examples. نأخذ هذا الكومباوند اللونجست chain اللي بتحتوي على ال OH اللي هي 1 2 3 4 5 بنتا. all bonds are single bonds pentane. الآن لأنه هي بتحتوي على إذا بنتين لأنه كل الروابط أحادية all bonds are single bonds، ولأنها هي بتحتوي على OH all pentanol. إذا if we count for OH from this side it's gonna be at position 2. If we count from the other side 1 2 3 4 gonna be at position 4. OH must be closer to the end. The position of OH must be closer to the end. Closer to the end number 2. أخذت 2. طبعا in the last code we write it pentan-2-ol. This is acceptable and this is acceptable, both accepted. Now the substituent is methyl CH3 methyl, and it is at position 2 1 2. Okay, look for the longest chain containing OH. The number of carbons must end up with all. If all bonds are single bond, pentanol. Position of OH must be the closest or the nearest to the end. Then we look for the substituents. We find the substituent here is one substituent is methyl. Let's go here to another example, and this example is alcohol, cyclic alcohol. So we name we give the name of the cycle cyclohexane, because all the bonds are single bonds. Cyclohexane, because we have two OHs. Diol. If we have one H, as we're gonna see later, cyclohexanol, because we have two OHs, cyclohexanediol. Now one of the all must have number 1, the another one must have the least possible number. If we select this is number 1, 1, 2, 3, 4, if we select this is number 1, 1, 2, 3, 4, so it doesn't matter. 1,4-cyclohexanediol, and both OH are cis, we can mention cis. In the last code, cis cyclohexan-1,4-diol. Another example, the longest chain containing OH 1, 2, 3, 4. Butane. All bonds are single bonds. Butane. 1 OH, butanol. Butanol. OH at position 2. 1, 2. 1, 2. 2 butanol, or butan dash 2 all. The substituent that we have, it's in the clean color, it's phenyl. Phenyl 2-butanol, and phenyl is existed at position number 3. 1, 2, 3. So 3-phenyl 2-butanol. 3-phenyl 2-butanol. Another example. The longest chain here, which is containing 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6, 7. We select the longest chain containing the double bond here, guys. If we have two longest chains, we select the longest chain containing the double bond. So the longest chain is 1, 2, 3, 4, 5, 6, 7, hepta. And because we have a double bond, heptene dash all. فwe can say heptene dash all, or heptene dash in dash all. Now the priority for all to have the least possible number. Least possible number for all, if we come from this side 1, 2, 3, from the other side 1, 2, 3, 4, 5. So we select the least possible number for all. 3 all. Hepta dash in dash 3 all. Now heptene 1, 2, 3, 4, 5, 6. Hepta 6, hepta dash 6 in dash 3 all. Now we look for the longest chain containing the all, and if we have the same, it must involved also the longest chain. So the name in all must have the least possible number or the closest position to the end. So it's a 3 and 6 for in. Now we find for substitution, we find that the ethyl is the substituent. Ethyl at what position? 1, 2, 3, 4, 5. At position 5. 1, 2, 3, 5. So the full name is 5-ethyl hepta 6 in 3 all. Here guys, longest chain 1 2 3 4 5 6, and 6 is iso here guys, 2 methyls. It's hexane. All the bonds are single bond hexane, and we have 2 OHs, diol, hexanediol. Now hexanediol, if count from this side 1 2, if you count from the other side 1 2 3, we select the closest to the end, 2 1 2 2 3 4, 2 4 hexanediol, 1 2 3 4, 2 4 hexanediol. The substituent here is methyl at position 5. 1 2 3 4 5, 5 methyl 2 4 the hexanediol. Here guys, the name is cyclopentane. So we call it cyclopenta. All the single bonds are single bonds. Cyclopentanol. Now cyclopentanol, if we have one OH only, it's by default, it's number 1. We don't need to mention number here guys, because OH is number 1. Now the other substituent, is bromo, so it's a bromocyclopentanol. The position from counting from all 1 2, 2 bromocyclopentanol, and they are trans 2 bromocyclopentanol. This is all about naming of alcohols. About phenols, we already discussed this guys. This is phenol. It has another group which is methyl and bromo. It's a tri-substituted. Methyl can be called toluene. Phenol, OH is phenol. Phenol has a priority over methyl, so the basic name is phenol, and phenol gets number 1. So the name is basic name is phenol. We got methyl now and bromo. According to alphabetical order, bromo is written before methyl, and because phenol is number 1, counting from here, methyl gets number 3 and bromo 4. 4 bromo, 3 methyl, phenol. Okay, 4 bromo, 3 methyl, phenol, and we already discussed this. By this we end up with naming. We will convert about the physical properties of alcohols and phenols. All the physical properties of alcohols and phenols is connected to the hydrogen bonding, and the hydrogen bonding in phenol and alcohols is strong bonding. This is how is it. Hydrogen is attracted to oxygen, partially negative, and the hydrogen every time connected to oxygen. This is hydrogen bonding. This hydrogen bonding is strong, very strong, so the boiling point of alcohols is very high compared to their molecular weight. So alcohol has high boiling points. الميثانol 65, الإيثانول almost 79, البروبانول 1 propanol 97, and you see this. As we know, as the number of carbons increases, the boiling point also increases. This is the first feature, that connected to the hydrogen bonding. They have high boiling points because they have strong intermolecular forces اللي هي hydrogen bonding. Solubility in water. If we speak about solubility in water, alcohols, they have solubility in water. Methanol is completely miscible, ذائب تماما. Ethanol same, propanol same because of the strong hydrogen bonding between alcohols and water. When we go to butanol, it starts to be slightly soluble. The solubility goes lower, and pentanol solubility goes lower, and hexanol is insoluble. Why is this? By increasing of hydrocarbonic part, the solubility of alcohol in water decreases. بزيادة عدد ذرات الكربون في الكحول تقل الذائبية. As we know, guys, that we have in alcohol two parts. The hydrophilic part, which attracts with water, as you see here it is in the reddish color, red color. This is the hydrogen bonding, which is the reason why alcohol is soluble in water. Hydrophilic attractive interaction with water. And as we know, the hydrocarbonic part is hydrophobic. It's repel water. This part repels water. So I have hydrophilic part interact and attracted to water, وhydrophobic part اللي هو hydrocarbonic part اللي هو hydrophobic part repels water. We refer to repulsive interaction here by this double side arrow, blue double side arrow. Here in propane, the hydrophilic part is stronger than hydrophobic part. So propane is soluble in water. Contrast في المقابل, if we to go to hexanol, the hydrophilic part, you can see here that the hydrophilic part which is attracted to water is small and weaker hydrophilic part, and what? Longer, greater, stronger hydrophobic part. By adding more carbon, the hydrophobic part became greater. Or repulsive interaction with water became greater as well. So in the meantime, the hydrophilic part became weaker compared to repulsive interaction. فالattractive forces, hydrogen bonding between the hydrophilic part, OH, with water became weaker compared to the repulsive interaction between water and the hydrophobic part اللي هو الهيدروكربونيك بارت. لما يزيد عدد ذرات الكربون بيزيد الجزء اللي هو ما بذوب في الماء الذي يتنافر مع الماء، بيزيد هذا الجزء ويضعف مقابل له الجزء الذي يتجاذب مع الماء اللي هو الهيدروفيليك المحب للماء، زي ما انتم شايفين في السايكلوهكسانول. وهنا أبناء الطلبة نكون قد غطينا في هذه المحاضرة القصيرة تسمية الكحولات والصفات الفيزيائية للكحول.